Algebra 1, Unit 9, Radical and Rational Exponents. We're going to start with a refresher. First of all, square root of 16, you can either type that in your calculator, or if you know 4 times 4 is 16, that tells you that the answer here is 4. Next, we have square root of 121 times square root of 144. The square root of 121 is just 11, and the square root of 144 is just 12. If I multiply those together, I get 132. Problem 3, the cube root of 8, you can definitely type in your calculator. You may need to ask your teacher how, but there is a button on there for cube root. Or you can say to yourself, what to the third power is 8? And it is 2, like I just spilled. So 2 to the third is 8, so that means that the cube root of 8 is 2. For problem 4, since we are multiplying like bases, we're going to take those exponents and we're going to add them. So x to the 1/2 plus 1/2 is x to the first. I'm just going to write that as x. And then for problem 5, we have a square root and a square. Those are inverse operations, kind of like multiply and divide or add and subtract. So a square root and a square cancel each other out, and we're just left with whatever's inside of the square root and the square. Some vocabulary that we're going to need for this concept. A radical sign is a mathematical sign called a root. So here's an example. And a rational exponent, an expression that represents both an integer exponent and an nth root. So it's going to be important for you to have this formula in your notes. If I have the nth root of x to the m power, that's the same thing as x to the fraction m over n. It's really important to know right here that that's a fraction. It's m over n. I commonly see students not understand that that's a fraction going on, so I just really want to point that out here. Here are some parts of a radical that we need to know. First of all, we call that little n the index. If there is no index written in a problem, then we just know that it's 2. Inside of our radical sign, the a, we call it the radicand. And then, of course, we have the radical sign. That's the little check mark looking symbol that we have going on here. Okay, as we get into the notes here, we're going to go ahead and list the first 12 perfect squares because we're going to need to use these today. Perfect squares are just the product of a rational number multiplied by itself. So the first perfect square I have is 1. 1 times 1 is 1. Next one I've listed is 4. 2 times 2 is 4. 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so on and so forth. Make sure you have these first 12 written in your notes. Okay, for these next 8 examples, I'm going to do the even ones with you and then pause the video and have you do the odd ones. First of all, problem number 2, square root of 256. We can just type that in our calculator and we get 16. That's because 16 times 16 gives us 256. Number 4, we're going to start by simplifying the square root of 16, which is 4. So I have 3 times 4, and then my final answer would be 12. For problem 6, anytime you see fractions in a radical, I want you to rewrite it as the numerator in the radical over the denominator in the radical. So see how I'm splitting the problem up here. Now, the square root of 1 is 1, so that's my numerator. And the square root of 121 is 11. If possible, I would simplify that fraction, but I can't simplify 1 over 11, so I'm going to leave it like it is. And the last one, negative 2 times the square root of 484. That's going to just be negative 2 times 22, because the square root of 484 is 22, which gives me negative 44. Okay, now I'd like you to pause your video and work out the odd problems and restart it to see the answers. Here are the answers I got. For number 7, be careful, that was a little tricky because 15 over 3 did end up simplifying. Here's a quick reminder of properties of exponents that we have learned so far. And in these examples you see we have the same properties but with rational exponents. So we have fractions going on here, but it's all the same whether we're adding our exponents or subtracting them or multiplying them, just like it was whenever we had integer exponents. In these next examples, we are going to be rewriting exponents without rational exponents. So we're going to put them into radical form, and we need to remember the formula that I've written on the top of this page. For example A, we have x to the 1/4. 1 is going to be our m value, and 4 is our n value. So if I put that in radical form, I have the 4th root of x to the 1st power, which is just the 4th root of x. We don't need to write the 1st power. For example B, it's important to notice that the 1/2 exponent is only on the x. So I'm just going to kind of put that in parentheses so you see that the 1/2 is for the x. So the 36 is not going to be in our radical. I'm just going to put the 36 out front and then write our x in radical form. So my n was 2 and my m was 1. Just like in example A, we don't need to write the 1 here. We don't need the exponent of 1. And then anytime our radical has an index of 2, we actually don't need to write that either. So we can just write this as 36 square root of x. In problem C, we have both the 81 and the t that have the exponent of 1/2, since it's written like this with parentheses. So I'm going to write my radical, and inside the radical is going to be the 81 and the t. My n is 2, so it goes for the index, and then my m is 1. Again, I don't need to write those. And I can actually simplify this one further because I can do the square root of 81. The square root of 81 is 9, so that's going to come out front, and my answer is going to be 9 square root t. My next set of examples I'm using a calculator on, and I want you to look for the X root button on your calculator. It's going to be helpful for you to ask a teacher how to use this button if you don't know how to do that. But once you do know how to use this button, we can type in each of these problems to our calculator, and we're going to get the answers of 3, 4, and 5.